Okay, let's dive in. Today, we're exploring the world of Michael Faraday, and he's, well, just an extraordinary figure.
Absolutely. Born into poverty, self-taught.
Right, completely self-taught, and he didn't just make discoveries, he fundamentally saw the universe in a new way.
He really did.
Yeah.
We're talking electricity, magnetism, light. He reshaped our understanding of all of it.
But the angle we're taking today, and this is the interesting part, is framing him as the man who made motion visible.
That's a great way to put it. Because where others saw these abstract forces, maybe mathematical constructs,
Acting across, empty space.
yeah, Faraday perceived something physical,
Mhm.
structured patterns, movement, like the universe was alive with motion.
And what's really fascinating, I think, is how his intuition developed, remember, without the high-level math his peers used.
Uh-huh. That's crucial.
It didn't just set the stage for, well, everything electric we have today. It also seems to perfectly anticipate this modern idea, motion theory.
Exactly.
Yeah.
Motion theory, just for context, is this framework for understanding reality, where fundamentally everything is seen as structured patterns of motion.
Not just particles or fields in the classical sense.
No, it suggests that particles, fields, forces, they're all different expressions of underlying motion patterns interacting, how these motions influence each other.
Okay. So that's our mission for this deep dive, really. We want to unpack how Faraday's specific genius fits right into that.
And hopefully offer you a kind of shortcut to seeing the world, maybe even reality itself, a bit differently.
Yeah, prepare for some real aha moments. Because once you start viewing the universe as this interconnected dance of motion, well, it changes things.
It really does. And to get Faraday, you absolutely have to start with his big, revolutionary idea, his rejection of action at a distance.
Right. The old idea that forces like gravity or magnetism just instantaneously act across empty space.
He just couldn't buy it. It felt wrong intuitively. Something was happening between two objects.
And something had to be moving between them.
Precisely. And he visualized this with his lines of force. But here's the key point.
These weren't just drawings for him.
Not at all. He saw them as actual physical patterns existing in space. Think about ripples in water.
Or the way iron filings line up around a magnet, that classic experiment.
Exactly. For Faraday, that wasn't just showing a field. It was revealing a real physical structure. Direct evidence of, let's call it, a structured motion gradient.
A motion gradient. So not empty space, but space filled with these invisible moving patterns.
That's the picture. And motion theory helps us put modern language to it. Faraday's fields can be seen as these structured motion gradients.
Meaning areas where these underlying, let's call them motion loops, have a specific pattern or flow.
You got it.
Yeah.
Imagine space isn't a void, but maybe like a subtle dynamic fluid. These motion loops are like tiny, organized whirls within it.
And a gradient is like a current, a specific flow pattern.
That's a good analogy.
Mm.
Real dynamic motions happening at a very fundamental level. That's what he sensed.
Okay, that really shifts things. Which brings us to electromagnetic induction, probably his most famous discovery.
Mm-hmm. Move a magnet near a wire.
And boom, you get electric current.
The standard explanation involves changing magnetic fields, creating electric fields, driving current. It works mathematically.
But through Faraday's eyes, especially with this motion theory perspective,
It becomes much more intuitive, doesn't it? Motion theory sees induction as fundamentally motion causing motion across systems without physical contact.
so moving the magnet, you're changing the local motion patterns, the rhythm of its own loops.
Exactly. You're altering the flow nearby. This change propagates. It influences the surrounding motion gradients, how they sync up.
And the wire being made of its own matter loops.
Its own organized motion patterns, yes. It responds to this new rhythmic influence. Its electron loops start to align, to synchronize with this incoming pattern.
creating a cascade of aligned motion, which is what we measure as current.
Precisely. He essentially discovered sync coupling, or sync transfer, how one system's motion can directly reorganize another's just through these propagating patterns.
Wow, okay. And then there's light. Faraday suspected light was electromagnetic, didn't he? Way ahead of his time.
Decades ahead. And he proved a link. He showed a magnetic field could rotate the polarization of light. The Faraday effect.
How does motion theory view light in this context?
It builds on Faraday's intuition. It suggests light is a high-frequency, synchronized wave of structured motion.
Like a ripple again, but maybe a highly organized, self-sustaining one.
Exactly, a sync propagation moving through space. So when Faraday saw that magnetic field affect light,
He was seeing direct evidence that light, electricity, magnetism, they're all connected.
all different expressions of the same underlying motion, just different frequencies, different patterns, different rhythms, it always comes back to motion.
Which makes his iron filings trick even cooler when you think about it that way.
Right. Legacy science says, see, it shows the magnetic field lines.
But motion theory says,
It's a literal visible map of how the matter loops of the iron filings, their own internal motion structures are aligning themselves.
they're responding to the sink pressure from the magnet's stronger motion gradient.
Yes, they aren't just passive tracers. Their constituent motions are actively joining the rhythm of the magnetic patterns. It's motion structure directly influencing matter structure. You're seeing it happen.
It's just incredible, especially considering he did this without the advanced math everyone else was using, just pure physical intuition.
Phenomenal intuition. He truly sensed that unity, electricity, magnetism, light, three faces of the same thing.
And motion theory kind of formalizes that, puts more precise descriptions on it.
It does. It helps us describe electricity maybe as a directional flow of these loops, magnetism as rotational patterns, light as that high-speed sync propagation.
But all fundamentally the same stuff. Structured motion, just doing different dances.
Different rhythms, different directions, different speeds.
Yes. So bringing this back to today, what's the big takeaway for us living now?
Well, fundamentally, almost everything electric you interact with,
Motors, generators.
the entire power grid.
It all rests on Faraday's discovery of induction. Our whole modern world runs on it.
Absolutely. But through this motion theory lens, his legacy is even deeper. He didn't just find induction, he found sync transfer.
This idea that motion patterns in one place can transfer and reconfigure patterns somewhere else without swapping actual stuff.
Exactly. It's a fundamental insight into how energy actually moves, how influence propagates through space.
Which really hammers home that his lines of force weren't just helpful drawings.
No, they were his way of describing direct evidence. Evidence that motion has structure, and crucially that space isn't empty.
It's filled with this dynamic, structured activity.
We're still living inside that vision he gave us, a universe shaped by the geometry of motion.
It's kind of mind-bending, really, thinking about Faraday. He never used terms like motion loops or sync density, obviously,
course not.
but he was acting as this translator between that invisible world of structured motion and what our senses could grasp.
He made the invisible tangible, in a way.
Yeah. He showed us that these things we label as forces might just be different aspects of something more fundamental, more unified, this underlying geometry of motion.
So maybe the thought to leave you with is this. Faraday had the courage to challenge the idea of empty space, of action at a distance. He revealed this hidden architecture of movement.
So after hearing all this, maybe ask yourself, what new motion, what unseen rhythm or pattern might you start to perceive in the world around you now that you've glimpsed it through Faraday's eyes?